We walk upon it every day, often without a second thought. We build our homes and cities upon its surface, creating bustling metropolises and quiet neighborhoods. But how often do we stop to think about what lies beneath? Beneath the concrete and soil, there exists a world that is largely unseen and unexplored. The earth beneath our feet is not a solid, inert mass. It is a complex, dynamic structure, constantly changing and evolving. It is a dynamic, living entity, a realm of unimaginable heat, pressure, and wonder. Volcanic eruptions and geothermal activity are just the surface manifestations of this hidden world. For centuries, humans have been captivated by the mysteries hidden within the Earth's depths. Ancient civilizations created maps and manuscripts attempting to chart the unknown. Ancient myths and legends spoke of subterranean worlds populated by fantastical creatures and guarded by powerful deities. These stories were a way for early humans to make sense of the unknown. Today, our understanding of the Earth's interior has evolved far beyond these early imaginings. Modern technology allows scientists to study the Earth's layers in unprecedented detail. Yet the sense of awe and wonder persists. The more we learn, the more we realize how much there is still to discover. Scientists now know that the Earth is composed of distinct layers, each with its own unique properties and composition. These layers include the crust, mantle, outer core, and inner core. These layers hold clues to the planet's formation, its internal processes, and the very origins of life itself. Fossils and mineral samples provide a window into the Earth's distant past. Exploring these hidden depths is a journey into the heart of our planet, a quest to unravel the secrets of our existence. Spelunkers and deep-sea explorers venture into these extreme environments, driven by curiosity and a desire for discovery. It is a journey that takes us from the familiar landscapes of the surface to the most extreme environments imaginable. From towering mountains to dense forests, the surface is just the beginning. We will descend into the depths of volcanic craters, where molten rock spews from the Earth's core. These fiery landscapes are a testament to the Earth's inner turmoil. We will explore vast cave systems, adorned with intricate formations sculpted over millennia. Stalactites and stalagmites tell a story of slow, patient growth, and we will plunge into the deepest oceanic trenches, where life thrives under unimaginable pressure. These underwater realms are some of the least explored places on Earth. Join me now as we embark on this extraordinary adventure, a journey to the center of the Earth. Together, we will uncover the secrets of this unseen world beneath our feet and marvel at the wonders that lie hidden in the depths. Our journey begins at the Earth's crust, the outermost layer upon which we live our lives. Though it may seem solid and unchanging, the Earth's crust is surprisingly thin, akin to the skin of an apple in comparison to the entire fruit. This outermost layer is divided into two types, oceanic crust and continental crust. Oceanic crust, as its name suggests, lies beneath the ocean basins. It is thinner and denser than continental crust, composed primarily of basalt, a dark, fine-grained volcanic rock. Continental crust, on the other hand, forms the continents and is thicker and less dense than its oceanic counterpart. It is composed predominantly of granite, a lighter-colored rock rich in minerals like quartz and feldspar. The Earth's crust is not a single, unbroken shell. It is fractured into numerous pieces, known as tectonic plates, which fit together like a giant jigsaw puzzle. These plates are in constant motion, albeit extremely slow, driven by the heat emanating from the Earth's interior. This movement, known as plate tectonics, is responsible for earthquakes, volcanic eruptions, and the formation of mountain ranges. It is a powerful reminder that our planet is a dynamic, ever-changing system. Beneath the Earth's crust lies the mantle, a thick layer of hot, dense rock that extends approximately 2,900 kilometers, or 1,800 miles, toward the planet's center. This vast expanse of rock is not just a static layer, but a dynamic and ever-changing part of our planet. The mantle makes up the bulk of Earth's volume and mass, accounting for roughly 84% of the planet's total volume. This immense layer is crucial in understanding the Earth's structure and the processes that shape our world. Unlike the solid crust, the mantle behaves like a very viscous fluid over geological timescales. This means that while it appears solid, it can flow very slowly, much like thick syrup or honey, under the immense pressures and temperatures found deep within the Earth. The intense heat within the mantle, reaching temperatures of up to 4,000 degrees Celsius, or 7,232 degrees Fahrenheit, arises from both the Earth's formation and the decay of radioactive elements within the mantle itself. This heat is a remnant of the planet's fiery birth and continues to play a vital role in its ongoing evolution. This heat drives convection currents within the mantle, similar to the way boiling water churns in a pot. These currents are slow-moving but incredibly powerful, capable of moving vast amounts of rock over millions of years. Hotter, less dense material rises towards the surface, while cooler, denser material sinks back down towards the core. This process of rising and sinking creates a continuous cycle that is essential for the movement of the Earth's tectonic plates. This continuous cycle of rising and sinking mantle material is the driving force behind plate tectonics. The movement of these plates shapes the Earth's surface, leading to the formation of mountains, earthquakes, and volcanic eruptions. As the mantle convects, it drags the tectonic plates along with it, causing them to collide, separate, or slide past one another. These interactions are responsible for the dynamic nature of our planet's surface. The interactions between these plates are responsible for the dramatic geological features we see on Earth's surface, from towering mountains to deep ocean trenches. These features are not just static landmarks, but are constantly being reshaped by the forces within the mantle, reminding us of the ever-changing nature of our planet. Our journey to the center of the Earth culminates at the core, a sphere of iron and nickel divided into two distinct layers, the outer core and the inner core. These layers are crucial to understanding the dynamic processes that govern our planet. The outer core, approximately 2,200 kilometers or 1,367 miles thick, exists in a liquid state due to the extreme temperatures, estimated to range from 4,500 to 5,500 degrees Celsius, or 8,132 to 9,932 degrees Fahrenheit. This molten layer is composed primarily of iron and nickel, with lighter elements such as sulfur and oxygen mixed in. This liquid iron alloy, constantly churning due to the Earth's rotation and the heat from the inner core, generates electric currents. These currents are not static. They are in a state of perpetual motion, driven by the convective movements within the outer core. The rotation of the Earth adds a spiraling effect to these currents, creating complex patterns of flow. These electric currents, in turn, produce a magnetic field that surrounds the Earth, extending far out into space. This magnetic field is not just a static shield. It is a dynamic and constantly changing force that interacts with solar winds and cosmic particles. The magnetic field lines, which extend from the poles and loop around the planet, are a testament to the power and complexity of these processes. This magnetic field, known as the magnetosphere, acts as a protective shield, deflecting harmful solar wind and cosmic radiation that would otherwise strip away our atmosphere and make life on Earth impossible. The magnetosphere is responsible for phenomena such as the auroras, which are visible near the polar regions and are a direct result of the interaction between solar particles and the Earth's magnetic field. At the very center of the Earth lies the inner core, a solid ball of iron and nickel with a radius of about 1,220 kilometers or 758 miles. This inner core is incredibly dense and solid, despite the extreme temperatures that exceed those of the outer core. Despite temperatures estimated to exceed 5,200 degrees Celsius or 9,392 degrees Fahrenheit, the immense pressure at the Earth's center, over 3.6 million times the pressure at sea level, forces the iron atoms into a tightly packed, solid structure. This pressure is so intense that it overcomes the natural tendency of the iron to remain in a liquid state, resulting in a solid core. The inner core, though hidden from view, plays a crucial role in maintaining Earth's magnetic field and influencing the dynamics of the planet's core. It is believed that the inner core grows slowly over time as the Earth cools, with the solidification of iron releasing latent heat that drives convection in the outer core. This process is essential for the generation of the magnetic field and the overall stability of the planet's geodynamo. Understanding the core is not just about knowing what lies beneath our feet. It is about comprehending the forces that shape our world. Scientists use a variety of methods, from seismic wave analysis to computer simulations, to study the core's properties and behavior. These studies have revealed that the Earth's magnetic field has undergone numerous reversals throughout history, where the magnetic north and south poles switch places. Such insights help us appreciate the dynamic nature of our planet and the critical role the core plays in sustaining life on Earth.